Welcome to Cascade Chemistry. This is Toxins Lesson 22, and it's about titrations. So in the last lesson, you learned that acids and bases neutralize each other to form water and salt. The following example, table salt is produced. So we can see here the hydrochloric acid and the sodium hydroxide to get together. The OH from the base combines with the H plus from the acid to make water, and the sodium and the chloride remain unreactive. This equation here, the way we've written it, is called a complete ionic equation. And this equation left over is the net ionic equation. And you probably remember that from the last lesson when we looked at neutralization. So we can see that those are the spectator ions. Remember that? The spectator ions, the ones that don't do anything. They're not involved in the reaction. And so here's the net ionic equation. This is what's actually happening. The H plus from the acid and the OH minus from the base come together to make water. The next example produces a different salt, sodium sulfate. But what's more notable is that the sulfuric acid, the H2SO4, has two H plus ions, two of them, that need to be neutralized. So it's going to take twice as much sodium hydroxide to neutralize the sulfuric acid. Excuse me. Because each of these sodium hydroxides has just one hydroxide, just one, whereas this sulfuric acid has two hydrogens. The complete ionic equation would look like this. Two hydrogens from the sulfuric acid plus the SO4 2 minus combines with two NAs and two OHs to make, in this case, two waters. So two OHs and two H pluses makes two waters. Excuse me. And the sodium and sulfate, again, are left over unreacted. So the net ionic equation, two hydrogens plus two hydroxides makes two waters. So that's what's happening in neutralization. The H plus and the OH neutralize each other to make water. In lesson 22, the focus is going to be on titrations and the calculations surrounding titrations. So there's really two questions that we're going to try to answer. What is the concentration of an acid or a base? And how much acid or base is needed to neutralize each other? So let's say you started with a container of some acid. And I'll just put an A in it for acid. So you have a container of some acid, and you want to know the molarity of that acid. You want to know its concentration. Well, if you take a known volume of base, so here's a base, and I'm going to put little lines on it showing that it's graduated, has marks on it, so we can measure how much we pour out. And this is a base. If we add some base to here and we measure how much we add, then we can use a calculation to find the concentration of this acid. Likewise, we can answer another question, and that is, let's say we have some acid and we want to neutralize it, but we don't want to add too little because then it wouldn't be completely neutralized, and we wouldn't want to add too much base because then the solution would be basic. We'd go past neutralized and we'd be basic. So we want to know how much base are we going to put in here? What volume of base should we put in here to completely neutralize this? So these are the two questions we're going to try to answer. We're going to try to find the molarity of the acid, and we're going to try to find out how much base is needed to add to the acid. And of course, both these questions can be asked the opposite way. We could make this the base, and we could make this the acid. And again, we could make that the base and that the acid. Okay, so what we'll do is start with a view in our book. And I'm going to start actually with this picture right here. This picture is what you're going to see when you watch the first video in the homework link It's entitled The Titration Experiment. It just lasts a few minutes, and it'll show you how to actually do this titration, how to find out the concentration of an acid with a known base or vice versa. The second video in the homework link is from Khan Academy, so it says KA Titration Calculations, and it'll show you some of the calculations I'm going to be showing today. So it's just another way for you to figure out how to do calculations. I would start by watching the video on the titration experiment and then watch my video. And then if you still need help, you can go back and look at the Khan Academy calculations video. So we're going to start on page 447, and we're going to see how the book does this. So here's the question. A 100 milliliter sample of aqueous sulfuric acid, H2SO4, is titrated with 2 molar NaOH. After 50 milliliters of the 2 molar NaOH is added, the indicator changes color at pH 7. So that tells us we're neutral when we're at pH 7. What's the starting concentration of the acid? Okay, so here's the equation. This 2 moles of sodium hydroxide will neutralize 1 mole of this acid. It's 2 to 1 because there's 2 hydrogen ions. So find the total moles of sodium that were used to neutralize this. So we're going to take the moles of sodium to find that. We're going to multiply the molarity of the sodium hydroxide times the volume. Remember, molarity times volume, the liters cancels, and that leaves us with the moles of sodium hydroxide. 0.1 moles of sodium hydroxide is the 50 milliliters of 2 molar. That works out to be 0.1 mole. Since 2 moles of sodium hydroxide are needed to neutralize every 1 mole of sulfuric acid, the moles of H2SO4 in the sample must be half the number of moles of NaOH. All right? So that tells us that if the concentration of the base was 0.1 molar, the acid must be half that concentration. It must be, in this case, 0.05 moles is what we must have neutralized. So if we take the moles that we neutralized, that's the N, and we divide it by the volume of the sulfuric acid, then we get the molarity of the sulfuric acid. Okay, up here I think I said molarity and I should have just said moles. So real quick, again, the first calculation finds the moles of sodium hydroxide, and we know that the moles of sulfuric acid would be half that, because again there's 2 hydrogen ions. There we are, 2 hydrogen ions in 1 mole. So the moles must be half of what we had in the sodium hydroxide, and if we take that 0.05 moles and divide it by the liters, that gives us the concentration. Okay, so that's how the book shows you. And here's the problem again, just to refresh what we just did. The 2 molar times the 0.05 liters is 0.1 moles of sodium hydroxide, and it's a 2 to 1 ratio, so it must be 0.05 moles of sulfuric acid, again divided by the volume of 0.1 liters or 100 milliliters gives us 0.05. Okay, what I want to do now is show you a really common equation that so many people use, and I'm surprised your book doesn't show you this, but I'm going to show it to you here because it's a very powerful equation. And you're going to see this up here, the same question, so I'll just slide that up. But I want you to see the 2 calculations compared to each other. So the equation goes something like this. M1 times V1, molarity 1 times volume 1, equals molarity 2 times volume 2. And we use this equation back in the dilution lesson. I can't remember what that was, toxins 16, something like that. And so the same equation can be used, but instead of doing a dilution problem, we're doing a neutralization problem. And so I'm just going to plug in the numbers. Here's our equation, just plug in the numbers. to molarity, that's the molarity of the sodium hydroxide, times its volume, 50 milliliters. And notice I don't have to change it to liters, so that's kind of a nice thing about this problem, or this equation. I can just leave it as milliliters. That equals M2 times the volume of the acid. So we want to know the concentration of the acid. Here's the volume of the acid, 100 milliliters. And so we want to find M2. M2 then equals, we're going to have to divide both sides by 100 to get our M2. So we're going to divide both sides by 100 milliliters. And that cancels there. And so that leaves us M2 equals 2.0 molar times 50 milliliters divided by 100 milliliters. And if we type that out on our calculator, 2 times 50 divided by 100, we're going to get let's do that here. 2 times 50 divided by 100 equals 1 molar. But remember, this sulfuric acid has 2 hydrogens, so just like we did up here, we have to say, well, wait a minute, it's a 2 to 1, so it can't be 0.1 molar, or in this case 1 molar, it has to be 0.5 molar. Let's see here. Okay, and there we go. That's our final answer right there, 0.5 molar. So this is the equation that I'm going to be using. This is the equation you'll see in the practice quizzes and tests. That's how we'll do them. And let's go on to this next problem now. In this question, instead of finding the molarity, this is problem number 3. This is actually one of the homework problems. So it's asking how many milliliters. That's what we're trying to find in this one, how many milliliters of 0.1 molar sodium hydroxide would be required to neutralize 2 liters of 0.05 molar hydrochloric acid. Now this problem is a little easier because we don't have to worry about changing the molarity here because of the 2 hydrogens. There's just 1 hydrogen here. So this will be quite easy. Here's how your book would solve it. Your book would do 0.05 molar times 2 liters is 0.1 mole of hydrochloric acid. And since the ratio is 1 to 1, we know that it must be also 0.1 mole of sodium hydroxide required to neutralize that hydrochloric acid. So if it's 0.1 mole of the sodium hydroxide, and we want to know what volume of sodium hydroxide to get to 0.1 mole, we're going to do, keep in mind this is 0.1 molar, so we're going to do 0.1, I'm going to write it this way, moles per liter, just so you can see this, times liters gives us 0.1 mole. And the liters cancels liters, but we don't know what that is. Okay, so what we really have to do is we have to move this number to the other side so we can find our liters. That is, liters will equal 0.01 moles. Oops, that was 0.1 moles. Sorry. 0.1 moles. And we're going to divide that by 0.1 molar. Moles per liter. So the liters equals 0.1 divided by 0.1, which is going to equal 1 molar, 1 liter. Actually, there we go. 1 liter is our final answer. Okay, if we solve it this way, I think you'll find this a little easier. We just plug in the numbers. Here's our molarity 1, our volume 1, our molarity 2, and our volume 2. And if you notice real quick, here we have twice the concentration. So this should be half the volume, if that makes sense. So to find V2, I have to divide both sides by 0.10 molar. And those cancel, leaving us with V2 equals, and that's going to be 0.05 times 2 divided by 0.1 equals 1 liter. There we go, 1 liter. So it's a real simple equation. I think you'll find it much easier than doing this. Just keep in mind that sometimes you have 2 hydroxides or 2 hydrogens in your acid or your base. And so that's how we find the volume of, in this case, the volume of sodium hydroxide needed to neutralize this much acid. Here we found volume instead of finding molarity like we did up here. Okay, let's go to this is problem number 4 in the book. Problem number 4 is a table, and it's asking you to fill in the table. So you'll need to do some calculations to do that. Although you can do some sort of quick work in your head here. So let's try some in our head, and then we'll check with a calculation. And then keep in mind, some of them you might, like this one here, I'm going to guess this one here, you're going to have to do a calculation. So let's start with this first one. It says, the table represents a series of titrations using 0.1 molar sodium hydroxide. So the sodium hydroxide is always 0.1 molar. And that's going to be used to determine the concentrations of 5 different samples of HCl. So here are 5 different samples of HCl. So they're going to have 5 different concentrations, or likely to have 5 different concentrations. So let's look at this first one. It's been done for us. So we sort of found this. If we started with 1 liter of the hydrochloric acid, and we added 1 liter of 0.1 molar sodium hydroxide, okay, then we added 0.1 moles, and that means 0.1 moles has been neutralized. And so the molarity is also 0.1 molar, just like this molarity here. Think about it again. It took the same volume, so the molarities must be the same. Okay, let's look at this one here. Here we started with 100 milliliters of this acid. We don't know the concentration yet, but we started with 100 milliliters. And we added 200, we added twice the volume of 0.1 molar sodium hydroxide. So if we had to add twice as much, it must be because this concentration is twice as great as this one. If you want to find the moles, again, that's 0.2 molar, 0.2 liters, 0.2 liters. And we divide that into the, we multiply that by the molarity. So that's 0.1 molar times 0.2 liters. That gives us the moles, 0.02 moles. And of course, that's the moles of acid that we neutralized. And if that was the moles of acid we neutralized, and we divide that 0.2 by 100 milliliters, or 0.1 liter, that gives us our concentration. 0.2 molar is our concentration. 0.02 divided by 0.1 is 0.2 molar. So again, we could see without really doing any calculations our answer to this, because it took twice as much base to neutralize this acid. So the acid must be twice as concentrated as the base, or 0.2 molar. Okay, so that shows you how to do this table here. Keep in mind, this is a little tricky. You have to go back to your previous lessons and remember that probably the most important calculation would be that molarity times volume gives you moles, because you'll be looking for the moles. And remember, molarity is moles per liter, so moles per liter times volume, they cancel, and that gives you the moles. That's how that equation works. So there you go, that's the table. If we use this table to calculate the molarity for, it looks like this one right here, molarity 1, that's what we're trying to find, the hydrochloric acid. In this case, I put our unknown on this side, times 100 milliliters, the volume, equals 0.1 molar, the concentration of the base, times the volume, 200 milliliters. And again, I need to move the 100 milliliters under this side here. That's what I did there. 0.1 times 200 divided by 100, and that will give us our answer, 0.2 molar. So just use that equation when you're doing this table to solve the rest of those. Okay, and finally, 2 more problems to do. This is problem number 5. Problem number 5 says a student mixes 100 milliliters of 0.2 molar hydrochloric acid with different volumes of 0.5 molar NaOH. Are the final solutions acidic, basic, or neutral? So what this is really asking is, have we added too much base or too little base to get to neutral? If we don't add enough base, then the solution is still acidic. If we add just the right amount of base, we're neutral. If we add too much base, then the solution will be basic. So to do this, what we really have to do is find the moles of the acid and the base, and then that tells us. So if we take the 100 milliliters and make that 0.1 liters, right? 100 milliliters, 0.1 liters, and we multiply that by the molarity, 0.2 moles per liter. The liters cancels, giving us 0.02 moles of hydrochloric acid. So that was the moles of hydrochloric acid. How much base did we add? 0.02 liters times the concentration, 0.5 molarity, moles per liter. Again, the liters cancels. And that leaves us with 0.01 moles of base. So we added only half the moles of base as acid. So this solution will still be acidic even after adding that base, because we didn't add enough base to get to neutral. We'd want to add 0.02 moles of the base to completely neutralize that acid. Okay, so that's 5A. We can also solve this way, although this technique I think is a pretty nice way to do it. We can solve this way. We can say, let's just use this equation here, 0.2 molarity, 0.2 molarity times 100 milliliters, 0.5 molarity times what volume do we need? So we're going to see how this number compares to this number here. And when we multiply that out, looks like I did it right here, we get V2 is 40 milliliters. That's how much we need to go with the acid. That's how much we need to get to neutral. Did we have that much? No, we didn't have as much as we needed to neutralize the acid. That's what this equation does for us. It gives us a neutral solution. So we did not have 40 milliliters, so we know we did not add enough base, so our solution must still be acidic. So that's the other way you can solve this, but this is kind of a nice way to do it here. Either way, though, either way. Okay, and finally, this is number 6. Number 6 goes something like this. Imagine you use 0.95 molar sodium hydroxide to titrate several samples of water. The volume of base needed to neutralize a specific amount of acid is given. So here's the amount of this 0.95 molar sodium hydroxide is the amount needed to neutralize 25 milliliters of the acid. So what we're trying to do is determine both the concentration of the acid and the pH. So what was the concentration, the molarity, and what was the pH before we added the base, before we neutralized it? Obviously, when we neutralized it, the pH was going to be 7, but we want to know what was the pH before that. So we'll use our M1V1 equals M2V2. And in this case, I leave my unknown on this side. Again, you can flip them around, it doesn't really matter. So M1 is our concentration of acid. So that's what we're trying to find, the molarity of the acid. And we know the volume, 25 milliliters. Here's the molarity of the base. Here's the volume of the base. And of course, we need to move the 25 under the other side. And when we do that, and we would do 0.95 times 46 divided by 25, we get 1.75 molar. So that's our first answer. That's the molarity of the acid. Now, you might recognize that that molarity is really quite concentrated. You probably remember most of our molarities have been something like 1 times 10 to the negative something. So here we are, we're 1 times 10 to the 0, which is a pH of 1. 1 times 10 to the 0, 10 to the 0 is just 1, so the concentration is 1, and the pH is 0, right? The pH here, 1 times 10 to the negative 1 is 1. So if the concentration is even greater than this, 1.75, then the pH has to be even less. Notice the pH is going down, has to be less than 0. So this is going to be kind of a wonky pH. It's going to be less than 0. Okay? So all we have to do to find the pH is take the negative log of the H+. And this is a strong acid. A hydrochloric acid. We'll assume all these in this problem are strong acid, and we'll assume that they're all monoprotic, like HCl. There's just one hydrogen, not diprotic like H2SO4. So that's an assumption we'll make for this problem, that they're all strong acids and they're all monoprotic. So the concentration of the acid will be the concentration of the hydrogen ions. So the concentration, 1.75, take the negative log, and you get negative 0.24 is our answer. So negative 0.24 is the pH, okay? Because the concentration is really quite high, greater than 1 molarity. So the pH is less than 0. There you go. That's the lesson. Don't forget to watch the titration experiments so you see a little bit about how that works. And if you want another kind of view, another voice to show you how to do the calculations, check out the Khan Academy. Bye now.